Okay, so another type of motor that we are going to see is a DC motor, which is a direct current motor, which is again widely used to translate electrical pulses into mechanical movements. And in the DC motors, we have only positive and negative LEDs, which is easy to interface. And connecting them to a DC voltage source moves the motor in one direction, and by reversing the polarity, the DC motor will move to the opposite direction. For example, 3-pin PC fan is a brushless DC motor which has got 4 permanent magnets on the rotor and 4 coils on the stator acting as electromagnets, and so on. So the no brush commutators pair increase reliability and reduces power consumption. So better adapted, no friction, produce less heating and better performance. And brush motors are generally made up of carbon. So you can see a simple figure of the motor, which can be connected to positive and negative terminal. And you can have a tachometer, which gives you a feedback for the sensor. And you can see that, again, by using the waveform generation, you can adjust the speed of the motor. So DC motor coils on the rotor cause the rotor to turn based on the Lorentz right-hand tool rule. They have fast reaction to voltage change and have good speed control and relatively simple to construct. So you can find more details about these motors in the literature. I'm not going to go into the details because this is a part of electrical theory course. So you just need to know how to operate it. That's what is more important for us. There are few formulas for the DC motor for the rotational speed and the shaft torque, which are quite important in order to design a DC motor. Um, Now, stepper motors, when we compare them, so stepper motors moves in steps, so 1 to 15 decrease, but the DC motor moves continuously. That's one of the differences. And in stepper motor, if we know the starting position, we can count the number of steps the motor has moved and calculate the final position. However, this is not possible with a DC motor. The maximum speed of a DC motor is indicated in rotations per minute, which is RPM. And you can reduce the RPM when moving a load and decreases as the load increases, so slower rotation. And a very important characteristic, electrical characteristic of a DC motors are they have high current and voltage ratings. So the nominal voltage can be from 1 to 150 volts, depending on the motor. And as we increase the RPM, this will increase. Now, the current rating is the current consumption actually. So when nominal voltage is applied with no load, that's going to be around 25 milliamps to 5 amps actually. And as I already said, as the load increases, the rotation per minute decrease. So unless the current or voltage provided to the motor is increased, which in turn increases the torque. Okay, so this is how the relationship between those are based on the speed and the torque. And with a fixed voltage, as the load increases, the current, the power consumption of DC motor also increases. So the overload will stall the motor, which can damage the motor due to heat generated by high current consumption. So DC motors can be operated either as a unidirectional, so clockwise or anti-clockwise rotations, or it can be a bidirectional, where we can achieve a bidirectional rotation with the help of relays or specially designed chips, and we can change the direction of the DC motor. So For example, this is a unidirectional control. So we can have a simple control directly by the microcontroller, AVR in this case. Now, PC fan, the controller was inside the fan package, so requiring only the supply. So this is what you can do. Or if especially if you are having a high power, then what you can do is you can separate the power supplies and the grounds of the motor and the logic through an opto isolator, as we already mentioned at the beginning of this lecture. So opto isolator prevents AVRs pins from the motor spikes, EMF, electromotive forces. So it's in order to not to damage the circuitries in the AVR, and especially when the motor has a high power. So this is not the case for the low power DC fans, but in high power motors, we can have the opto isolators and some driver transistors in place. So when we talk about bidirectional, we can give an example of a H bridge. So if we just close one of those switches and on the upper side and one of the switches on the lower side, we are actually allowing the current to go from one to another. So for example, if we close the switch 1 and switch 4, the motor will rotate in the clockwise direction. So it's going to be like that. Okay. And if we do it other way around, where we close the switch 2 and switch 3, then it's going to be anti-clockwise rotation. And if all switches are on which they are closed, it's an invalid, so it will short circuit power to the ground, and it's not going to operate properly. So this is how we can use the motors. Let's see an example now. So switch is connected to a pin A7 of the AVR. So write an assembly program to control an H bridge where DC motor moves clockwise if PA7 is 0 and counterclockwise if PA7 is 1. So port B 3 down to 0 pins are used to drive the switch controls. Okay, so let's see how we can do that as a code-wise. So just to make sure, for clockwise rotation, 1 and 4 has to be on, and for anti-clockwise rotation, 2 and 3 has to be on. Okay, so 2 and 3 for anti-clockwise and 1 and 4 for clockwise. And in this case, 0 will do clockwise, so 1 and 4, and 1 will do counterclockwise, 2 and 3. Now, in this case, we have to set first the ports. Either you can set them by SPI, or you can just say LDI R16. Then we can say 0 hex FF. So out port B, out DDR B R16. So port B as an output. Now we can also use SPI instruction, SPR DDRB 0, 1, 2, 3. Okay, so if we are just want to specify specific pins, that is also possible. And this is one way of doing that, but I'm going to show you the other way. So because it will be easier to control it that way. So this is one way, but it's one SPI DDRB 0. So make PB0 an output So this is going to be switch 1, then SPI DDRB 1, make PB1 and output. This is for 2. And then SPI DDRB number 2. So that make PB2 and output. Switch 3. And finally, final one, SPI DDRB number 3, make PB3 and output for switch 4. So we have got all the output pins, which is going to be connected to H switch, H bridge. And we also need to have DDRA as a switch. So pin 7, it's going to be make port A7 an input as a switch. Okay, so based on that, we are going to decide if we are going to go for a clockwise or anti-clockwise. So what we need to do is we have to check if this pin is set or not. If it is set, then so moves clockwise if it is 0 and counterclockwise otherwise. Okay, so we can say SPIS pin A7. So that means skip next if pin A7 is set. So what are we going to skip? Now, if pin A7 is set, that means we have to skip the counterclockwise. Okay, so we are going to do counterclockwise if it is set. If it is not set, we'll do the clockwise. So what I can say is, if it is set, our jump clockwise will be skipped. So rather than jumping to somewhere else, if PA7 equals 0, go to counterclockwise. Sorry, go to clockwise. Okay. So clockwise P0, PA7 0. Okay then. So we are going to skip that one if this is set. So otherwise, what we need to do is, if we go back here for the clockwise, counterclockwise. So counterclockwise, switch 1 and switch 4, which are DDRB0 and DDRB3, right? So that means what we can do is CBI port B. So bit 1 is going to be 0, which is switch 2. Okay. So switch 2 will be 0. Then CBI port B 2. So switch 3 will also be 0. And then SPI port B 0, then switch 1 will be 1, and SPI port B 3, then switch 4 will be also 1. So then we have to do, if we just reach here, jump, monitor, keep monitoring it. So monitor, it has to go back over here and check for the new one. Otherwise, this is gonna do clockwise. So in this case, let me put this down as well. CBI port B 0. So switch 1 equals 0. CBI port B 3. Switch 4 equals 0. It's just the opposite of what we have done. And then SPI port B 1. So switch 2 will be 1, and SPI port B 2, which is switch 3 equals 1. And then this is going to jump to monitor as well. So this is how we can monitor it. This is how we can turn on the switches for the H bridge by using this example given, the question given. And we can easily monitor the pins, and we can either turn it clockwise or anti-clockwise. Okay, so we can use a motor driver like L298N, which can supply high current directly to a motor. The good thing about this is it can deliver separate voltage levels with large enough currents at two outputs, so the switches are no longer required at this point, and we can use multi-watt package L298N. And of course, you will need a driver and opto-isolator in between. So that's the circuitry inside of it. And another motor driver is L293, which can also be used. It's a quadruple high current, half H driver, and so there's a pair forms a full H, so you can use two of those together. There will be a protection diodes in there for internal and save cost. So these are some of the devices, discrete devices available on the shelf, which you can use it in your system. So that's all you need to know about the motors as well. And in this part of the lecture, we have talked about the relays, opto-isolators, high current drive, and things that we require, the stepper motor and the DC motors. Now, in the last section, we are going to see how we can control these type of motors by using PWMs.